would like to pass over to the presentation about the project Ecobulk. This will be held by Marko Wilki. Marko Wilki is the CEO of Konenor in Finland. He has a 40 years experience in the plastic industry, specializing in plastics processing, equipment and processes. The last 10 years, he has focused on composites extrusion from waste and recycled materials. With Konenor's rich 25 years history of patents and innovations, Marko has extensive experience in bringing new technology and products to the market. He is also involved in a few European Union funded projects in this topic. Now I would like to hand over to Marko to present his presentation about the project Ecobulk. Marko, the floor is yours.
Thank you, Arne. So project Ecobulk, let's have a look at what that is all about. In one short sentence, it is about closing the loop on the composite materials value chain. And in some key messages, it's a multidisciplinary approach to closing the loop of composite products, materials, and coordinated by UPC in Spain. A large-scale demonstration of circular economy solutions with 26 beneficiaries all over Europe, with a total budget of 12.2 million, duration of 4 years with a half-year extension due COVID-19, and dealing with 3 application and product areas, being in the automotive, furniture, and construction. So where are we now? In broad terms, one could say that the baseline for prototype of products has been cleared. We have been working on the circular design framework, design workshops, prototype product development, as well as materials for those, followed by production, testing, and assembly of prototypes. And at the moment, we are moving to prototype use, finalizing the LCCAs, collecting end user feedback, and actually getting quite close, ending the project by November this year. So obviously, in a large project like this, in 15 minutes, you don't get into everything. So myself being the task leader for work package 4 demonstrations, I have chosen to focus on the practical applications and demonstrations to give you more in-depth information on those. First of all, when starting to create the project contents, you obviously have to consider the strategies, well, also about material use or component reuse, maximum flexibility for reuse. And obviously, all this consideration need to take into account that the capacities of the beneficiaries, the participants, and taking the most out of it to a successful outcome of the project. Secondly, there are generic circular economy principles to be applied about enhancing the material flows and material efficiency, about design aspects, prolonging the lifetime, reusability. All these issues need to be taken into account. And as soon as you have applied these into the project contents, then actually you can go and follow on into the deployment. So basically, the demonstrations are all over Europe, as you see from the map here. There are several partners providing services for each other in terms of defining the feedstock, producing raw and developing raw materials, producing the products, and followed by the assembly of the products. In automotive and furniture, this is very much so, but in the construction area, all the materials have been developed, products have been developed and produced by company Konenor in Finland, and then just distributed to the sites for the assembly work. First of all, talking about the furniture prototypes, where the leading company is Moretti Compact in Italy for new modular furniture prototypes. It is a sort of cubic modular element to be utilized in different ways that you'll see in the next slide, where the material is recycled particle board with eco-friendly binder, produced by company customer in Turkey. Here we see a typical setup of or illustration of the cubical elements used in seats, cabinets, tables, as well as a bed. This would be ideal, for instance, in student dormitories and equal applications where the main characteristics would be disassembly, reassembly, and durability. Second example comes from Italy company NTT, producing non-wovens from recycled material waste, where a sofa has been produced like this and tested for consumer perception in France by FCBA. Following into the automotive, where we have 3 participants, Maya from Spain, for a new type of central fascia assembly, as you see on the left-hand side, and then CRF, meaning Fiat in Italy, for the command frame assembly. Again here, dual layer assembly, working with virgin materials, with recycled materials, with various polymer types as well as fibers, but having circularity in all of the materials. Here we see a couple of the examples being produced in different versions. In the Meyer central fascia assembly, utilizing PLA, which is a bio-based polymer developed by Tecnara in terms of having fibers, glass or natural fibers, and then utilizing other type of polymeric materials like ABS and polypropylene, again with glass fibers and natural fibers in different contents. On the left-hand side, we see the prototypes of Meyer, and on the right-hand side, the common frame assembly in different versions developed by CRF. The material partly being also developed by Coventry Composites in the UK for these prototypes. In the UK, we have a company Microcab developing their new hydrogen fuel cell driven car, where the central console assembly, as you see in the photo, has been developed utilizing the pultruded new materials from Coventry Composites. The materials are 2 different ones. One is polypropylene with natural jute fibers, and the other one polypropylene together with carbon fibers. With Microcap also, they have considered over period of use of the product controlled upgrade and refurbishment, when different ages, different components should be upgraded or refurbished, utilizing the anticipated need for this as well as the lifetime of the component. Moving on to the final construction side, which is unique in that sense that it is utilizing recycled and waste from FRP products as a reinforcement in extruded multi-layer materials and products. And I would like to emphasize that recycled composites is a patented invention of Koneno, which has also developed and produced both materials and all demo products in this project. So for outdoor construction especially, it is good for resisting water and UV. It doesn't have any swelling, splitting or rotting. It is colored at production. There's no need for painting. It has very good mechanical properties, fit for the purpose, and especially retaining the original properties over time. The polymer matrix is recycled thermoplastics, either polyethylene or polypropylene, and all of these materials are circular for recycling purposes. On the left-hand side, you see in the small picture the multi-layer concept, which is utilized in all of the components, either it is a solid or a hollow profile or panel, or whichever the component is. The first demonstration site to be presented is in Finland, which is a new MotoGP racing track under construction called Kymmering, where we have developed and supplied 150-meter visitor benches to be displayed and located around the track, meaning 3-meter long benches, 50 units. The other one is the flagman shelters, 10 units around the track, as you see on the illustration photo on the right side. The second demo site is found in Portugal. It is a company Lipor in their natural park, where they have constructed a drinking fountain as well as a rest place around the tree and a waste bin from the components supplied by Koneno. Moving to UK, where 3 universities, Warwick, Coventry and Cranfield, have used about the same design of a gazebo on outside of the university. And as you see here, the gray color is in polyethylene, while in the previous photo, the beige was made in polypropylene matrix. Polypropylene is better for maintaining its rigidity in hot climate, and therefore for Portugal, polypropylene. When we come then to the cold climate, UK and Finland, where the freezing at the winter time may be an issue, we have chosen to use polyethylene. Together with the FRP waste from end-of-life products. In France, we have certain companies interested in benches and seats, and these prototypes have been produced by FCVA participating the project. One special issue in the Koneno technology is the use of FRP waste, where we have been working with a couple of companies in Holland providing the waste from end-of-life wind turbine blades. And as you see in the link here, blade recycling is announced to be the top priority for the wind industry. And also actually the same applies to the boating. On the top you see the anticipated waste generated in the wind industry over years to come, and it is an enormous amount of material that needs to be recycled. And that is one approach we have taken to provide a solution here. So first of all, it starts with the design challenges which have been dealt by TU Delft. First, if possible, product reuse and recovery of structural components and creating certain use for these components. The second area is the materials recovery, where you can take certain parts, even in the smaller structural parts, use fasteners and connections, and utilize those as they are. Finally, when going into secondary recycling, the material will be shredded down and utilized as a reinforcement together with recycled plastics in Koneno technology to extrude or injection mold different new components for various applications. Shortly about the technology of Konenor, it is a simple low-cost process technique for agglomerated recycled composites at low energy consumption and no waste. In the project Ecobulk, it has been demonstrated, and next is the industrial scale-up by their manufacturers. When going into injection molding applications, typical product is a granule in given size, and also this can be achieved by compounding the agglomerates in compounding equipment, and even more applications become then possible with this new material that one could call short fiber thermoplastic granules, which are from recycled origin. This has been proven in this project by company ISWA in Spain with the agglomerates supplied by Conenor. Obviously, it is important that all our information and outcome is available for the market, and we are creating a stakeholder platform with a database, the business support app, tracking and labeling system, as well as quality assurance system. This will be accessible for the suppliers, end users, recyclers, service providers, retailers, manufacturing industry in a loop via a QR code that you can access, for instance, by your phone. Finally, of course, there are other activities around creating the framework for the business, like providing the LCA, LCCA, which is ongoing by FCBA in France, working on the business models, value chain, in the UK by company Oakden Hollins, reverse logistics and policy recommendations created by Italy in Spain, testing and proving the circularity by CNR, Italy, IPLAS, Spain, Belver in Spain, and standardization and the SEN workshop agreements by UNE in Spain, and other activities not even mentioned here. I hope this has been a short insight into the project Ecobulk, and should you like to learn more, please follow the project, check out the Ecobulk website, sign up for our newsletter, follow on social media. It is all there waiting for your interest. Thank you so much.